All right. Okay. Hello and greetings. Welcome to my channel. I am Professor L and hosting a live stream for math engagement. So if you are out there and you have a math problem you'd like me to work, you're always welcome to post that in the chat. In the meantime, I did pick a problem out, and I am still on the subject of oblique triangles. Remember, you can use law of cosines or law of sines to solve for missing values in a triangle. And this is an application problem that is solved very similar to the way that I solved the one yesterday. However, it looks completely different initially. So same solution, completely different problem, and it's just showing the versatility and the wide variety of applications that you can use triangles to solve. Anyway, I hope everyone's doing well. Happy Tuesday, and yeah, so I'll just get into it. All right, so I have decided to go ahead and write this problem out. And kind of take my time. So we've got an airplane. And it heads in the northerly direction. At an airspeed of 300 miles per hour. It's not a period yet. All right, it says while a wind is blowing due east at 50 miles per hour. And then it asks us to find the heading. It says the resultant. The resulting ground speed. Getting black all over my face. Is 330 miles per hour. Find the heading. Okay, so all right, we're going to first begin by defining what these words mean. And airspeed and ground speed is different. in regards to, so the airspeed doesn't factor in the wind, but the ground speed does. So what the ground speed is it's the resultant vector of when you add the two vectors together, essentially. So we're going to set up our diagram and factor in the wind speed. So I'm going to go ahead and draw that out. So we have that. We also have the wind is blowing due east at 50 miles per hour. And so what you have, if it's due east, the wind is defined from the direction it originates from. So if it says it's blowing due east, then it's actually a westerly wind. And so this right here is telling me that the vector is moving. So remember the compass, that it's north, south, positive direction east, and then the negative direction would be west. So do we get everything else that we have defined in here? The heading is the direction that the nose is pointing. And I believe that they use an azimuth for heading. We can use an azimuth heading, or we can actually just use the what's it called? Oh, no, I'm not remembering what it's called, the compass. So we'll go ahead and just pause for a minute, and then I'll start working this problem. Let's see if I can get a good marker for this. This one's a good one. So yesterday I feel like I was just in too big of a hurry, so I'm going to just take my time and pause after I write this and try to not be in a hurry for it. All right. So I'm going to go ahead and set up my diagram, my first one. So the first one, I'm going to draw a vector because it says my airplane heads in a northerly direction. So north, my first vector. And what else does it say? At 300 miles per hour. So we'll just label this 300. Remember, distance equals the rate times the time. So it's 300 miles per hour. So if we were just thinking about in the unit of 1 hour, it would travel 300 miles. And the same thing for the wind. If it's moving, so we have north, here we'll go ahead and put our compass in here, south, just to remember. We've got east. Let me redraw it, hang on a second. It's not what I want to do. So we'll use our compass. We'll just put one right here. North, south. And we've got east and west. So if I have a wind that's moving, blowing due east, then really it's moving in the westerly direction. So we've got this wind that's pushing the plane this direction. and we want it to be 50 miles per hour. So we're gonna have to come up with a unit measure. So if I say 300 is this long, let me get my ruler out. And this one is approximately 10, so it'd be 3 times as much. So okay, so we just have to do 5. So 50 from 300 would be about like this. So maybe it wouldn't be, hang on, it'll be a little bit longer. Let's make it a little bit longer. $50 divided by 300. Now I didn't even realize I was gonna be doing proportions. Okay, I think that's about it. So what we're doing is we're looking for this resultant. So we actually have it. It says it's 330. But it's this, that we're looking for this angle. So we can't really draw that resultant yet. And it says it's a northerly direction. We don't know if it's due north or what. So all right, I think I have my vector drawn. And we'll just try to, it's this vector right in here somewhere. So I know that I'm looking for an angle, we'll just call it alpha here. But really what we're going to be doing is we're going to be setting up the triangles. So I'm going to go ahead and resketch my triangle here. And I have this 330 is the resultant. I have 50 degrees would be the mile, that would be the wind speed, and then I have 300, my airplane. Do I want to attempt to draw an airplane? Okay. This is without even looking at a picture or anything. That does not look like an airplane. All right, how would I draw it? Should I cheat and look up a picture? An airplane stick figure. So we've got the wings. Got the nose. Like maybe a paper airplane. It could be a bird, it could be anything. And then we have a tail. That looks like a shark. All right. I got put on the spot. I didn't realize I was going to draw an airplane. And then we have to have a propeller. Okay. That's some sort of propeller, I don't know. All right, so we've got this airplane that's moving and the wind is affecting it. All right, so what we're doing is we're looking for the actual heading of that plane that is going to be this angle right here. Wait a second. The nose, this is the heading here. So it's going to be actually this angle, this one. All right, so we have this triangle. So we'll say A, B. Actually, I want this one to be B. For some reason, I like for my hypotenuse to always be C. So we have to do that. And then A, and then this one will be little b. And we're going to use law of cosines again. And then we'll say c squared equals, let me not mess it up today, a squared plus b squared minus 2ab times the cosine of c. And now I'm just going to plug in what I know. So we have, this is the angle that we're looking for right here. It's going to be the heading, not this one. All right. So we have c squared. So let's make a list real quick. So we've got c, little c is 330. It's my resultant. And then I have a is going to be, we'll put that as the wind speed. And we'll say, wait. Hang on, what did I already have? I had b as the wind speed, sorry. Little b is the wind speed, and then little a will be my speed of my airplane, A for airplane. And then I'm looking for cosine C. So that's going to be my variable. And let's try this one more time. So we have 330 squared, and that equals 300 squared plus 50 squared minus 2 times 300 times 50, and that's cosine C. And then let's go ahead and get the calculator out. So 330 squared is 108,900. Because law of cosines, you end up having to take pretty large numbers. So 300 squared, 90,000. And then 50 squared, 2,500. And then we've got 2 times 300 times 50. $30,000. Times the cosine C. And so now we're just going to combine like terms and we're going to solve for cosine C. So we're going to add these two and then we're going to subtract from both sides. So we've got 90,000 plus 2,500, 92,500. Those are even numbers. I didn't have to use the calculator, but I get used to it. Putting in mechanical operations, and I just do it. All right, so I have minus 30,000 times the cosine of C. We're going to subtract this value from both sides. So I've got 92,500. These are going to go to 0 and end up right in the corner again. So I've got 108,900 minus 92,500. And that is 16,400. And that equals a negative 30,000 times the cosine of C. And then we're going to divide off negative 30,000 from both sides. So we're going to get cosine C equals 16400 over 30,000. And that's negative. All right. So you have this thing going on here. You've also basically, here, I'll put it up here. You have these quadrants, and you have to remember first quadrant, they're both positive, and the second quadrant, cosine's negative and sine's positive. And then third quadrant, they're both negative, and then the fourth quadrant, we've got cosine positive and sine negative. So we have a negative cosine. And so we have to be either here or here. So for the compass, that wind had to either, I'm headed north, I have to be over here somewhere or here. So depending on how strong that wind is affecting my ground speed is where I'm going to be headed. So it's nice to know that before you go and put this calculation in. You have a negative cosine, you're going to be this direction in the west. All right. So let's figure out what this is. So negative 16400 divided by 30,000. And I'm getting cosine C equal negative 0.54, and then it's 6 repeating. So to figure out, to solve this, you have to use the inverse cosine. So we're going to say arc cosine of that argument, negative 16400 divided by 30,000. And that is going to equal C. And I'm getting, okay, so I'm getting 123.138. So if we remember, so if you subtract 90 from that, so you're over here, 123 somewhere. And so what it is you end up with this bearing right here. Of 33 degrees. Let me see if it'll DNS it. Okay, it did. So we've got 33 degrees. This is this heading. The actual heading of your aircraft is 33 degrees, 8 minutes, and 19.074 seconds. So the heading, 33 degrees, 8 minutes. All right, see if that helped. That did help a little bit. It stretched it out. This might be the conclusion of oblique triangles. I did want to at least attempt one of these more simple problems about navigation. They do get very complicated, and I remember being puzzled by them years ago. So hopefully that helped a little bit. You know, in the age of technology, we have all this AI, and we have all of this digital capability. I think that I see a navigation away from that. People need people, and I don't know, maybe it's just me. I would much rather see an imperfect, annoying person work something than just have an AI or completely fabricated. I mean, anyway. All right, enough rambling for one day. That's Tuesday, and I somehow managed to almost make 25 minutes out of that. And so we'll go ahead and call that good. And yeah, if you watch my video, thank you for that. And yeah, if not, maybe I'll catch you in the future. Hopefully I am getting better at this, because it's my intention to help. And so yeah. All right. So I am happy with the progress. I was kind of worried about this one just because I'm not an expert, and you just never know how it's going to work out. So again, Professor L, and I will be back again tomorrow, same time, same place. And again, I hope that everyone has a great rest of your evening and or day, depending on what time you watch this video. And yeah, I'll just see you again next time and say bye for now.